present this work. I hate to stand between people and lunch and sun, so I don't know if I have to cut off in the middle. But so this is about causal interaction, and it's a joint work with actually undergrad Naoki Agami, who came last summer asking to be RA, and I said sure. And then we ended up writing a paper. So it's a very smart undergrad who's, I think, applying for a PhD program, got into some of your programs. So you admitted him, you might want to recruit him. Very smart student. Okay, so the causal interaction. So I used to think interaction is a very simple thing. And I think I was real wrong. So you might want to understand all these nuances, which I didn't before I started this project, but we'll see how people react. So just to motivate what the causal interaction and causal inference, in particular, from my perspective, I think it has to do a lot with the heterogeneity and heterogeneous streaming effects. And you can think about it in two ways. One is the moderation. That's just thinking about how do treatment effects vary across individuals. So as a function of the characteristics and so on, the same treatment may have very different effects depending on who you are. Right, so you can ask questions such as food benefit or is harmed by a particular treatment by thinking about this moderation idea. So this is really about interaction between the treatment variable and the pre-treatment covariates, like your characteristics. Right. And the second way, which is the focus of this talk, is causal interaction. That's a name sort of in the literature, statistics literature. So here, you're asking the questions about what aspects of a treatment are responsible for causal effects. So if you have, say, policy as a treatment, policy is usually a bundle of lots of things, and you want to think about what are the aspects of this particular treatment have effects. So as an example, I got involved in randomized evaluation of Mexican universal healthcare, but it wasn't just giving health insurance. It was all about building the hospitals, and whole process of the intervention it consists of a lot of things. Another thing that you might want to ask is, using the idea of causal interaction, is what combination of treatment is most effective. So if you have multiple treatments, like what combination? So you can think of policy intervention as a single treatment, or you can think of it as a combination of lots of different treatments. And so this is really about interaction between treatment variables, right? So those are two different things. And it's actually statistically also different, especially in the randomized experiment, because you're randomizing the treatments, whereas the covariates are not, pre-treatment covariates are not randomized. Now you don't have to stop here, right? You can go even a step further. It's thinking about individualized treatment regimes. So this is now very big in statistical literature on causal inference. So the question here is what combination of treatment is optimal for a given individual? So this is now you're thinking about not only interaction of the treatments, but the effect of multiple treatments being different across different individuals. Right? So in the medicine, if you has some disease, the doctor may decide, depending on who you are, doctor may administer a different combination of the treatments. So all of that is to emphasize the interaction plays an important role in causal inference. And here I'm going to talk about causal interaction, which is the second one. And if you have, people have questions, just feel free to ask, because I can stop in the middle and quit, or I can skip some parts of the slides. It's pretty flexible. So. All right. So the first thing I want to emphasize, which it's now obvious to me, but it wasn't obvious to me when I started. There are two interpretations of causal interaction. So interaction among treatment variables. So the first is what I call conditional effect interpretation. So here, you're asking the question of, does the effect of one treatment change as we vary the value of another treatment? Okay, so that's a conditional effect. So it's similar to moderation, except you are thinking about another treatment, how the effect of the one treatment changes when you change another treatment. So thinking about the famous experiment of sending out different CVs to potential employers, you might be thinking about, does the effect of being black change depending on whether an applicant is a male or female? So the effect of being African American relative to, say, being white may be different depending on whether you're male or female. Okay. So this is useful for testing moderation among treatment variables. Okay, so that's the first. So this is, I think, what we social scientists think is typical to understand interaction. The second interpretation, which is similar but slightly different, and you see, and depending on the context, is the interactive effect interpretation. That's the name I came up with. And so here the question is, does a combination of treatments induce additional effect beyond the sum of the separate effects for each treatment? Okay, so if you think about this previous example, that's being a black female. It says something about being black female is very special and induce additional effect beyond just effect of being black or being female. Okay, so you can think of it as like an additional effect that you get because this combination is something special. That's why I call it interactive, because by these two treatments interacting, there is something beyond just the sum of the parts. Okay. So this is useful for finding effective treatment combination in high dimension. Okay, and I'll talk more about this, but when I say high dimension, if you have multiple treatments, not just like 2 by 2, but multiple, 3 or 4, and then maybe each treatment has different levels, like 3 or 4 levels. Okay, when you have that, as you see, the number of treatment combinations increases very quickly, and so you won't be able to estimate each combination, effect of each combination separately, and even if you can, looking at them is not going to make sense. So what you want to ask yourself in those situations is, what are the kind of possible combinations? What are the possible combinations that bring additional effect to the table? And I'll give some examples so that you can see what it looks like in real experiments. Okay, so before I get to the high dimension, I want to start with 2 by 2, because all of this actually works in the 2 by 2 as well. But it's just that in the 2 by 2 case, it's really not necessary to think this hard about it. So if you are the kind of person, you're going to run experiments, but all you're going to do is just 2 by 2, you can look at this slide and then maybe stop there. In which case you can start eating lunch. Okay, so suppose there's 2 binary treatments, so A and B. And so A is 0, 1, and B is also 0, 1. And so we all know the potential outcomes, there are 4 potential outcomes depending on whether 0, 1. Okay. It turns out that interaction effect has the 2 different, I gave you the 2 different interpretations, and you can formalize this using the potential outcome notation. Okay? So the conditional effect interpretation is basically this, which is that first part says it's an effect of A going from 0 to, okay, this tiny red thing, can you see? All right, so effect of A, so A go from 0 to 1, holding B equal 1. Okay, so that's the effect of A when the B equal 1. And the same thing here, effect of A 0 going to 1, but the holding the B equal 0. So that difference is the interaction effect. So this is the conditional effect interpretation. Okay. It turns out the same exact quantity, same number, right, can be written in the following way, which is the interactive effect interpretation. So here, I'm looking at the joint effect of A and B. Okay? Now, I'm subtracting effect of A when B equals 0, and then effect of B when A equals 0. Okay? So this is the additional effect that A and B brings together beyond the sum of the effect of A and effect of B. Okay? And if you do a little bit algebra, you'll see these two things exactly the same. Right? So that's what I mean by when we have interaction effect, so you might get a number like 3. Like how do you interpret that 3? Well, you can interpret it in 2 ways. Okay. All right. So it's the same quantity, but 2 different interpretations. Okay. So what's strange about this, at least to me, is that, right, it feels like totally different purposes, but it's the same number. Okay. The one thing I want to emphasize here is that interactive interpretation requires the specification of the baseline condition. So in the 2 by 2 case, I'm setting, when I'm evaluating the effect of A, I'm setting B equals 0. And when I'm evaluating the effect of B, I'm setting A equals 0. That's because AB00 is a baseline condition. Now, I could have set the B equal 1 here, or A equal 1 here. Still, I can evaluate the effect of A and B. But I chose to evaluate it holding the other treatment at the baseline condition. And it turns out that choice is going to make a difference in the high dimension. Okay? Here, you don't really have that situation because you're already saying I'm interested in how the effect of A changes when the B equals 0 versus B equals 1. So that's like substantively motivated. Okay? But here, the second interpretation, there may not be a strong substantive motivation. When we go to high dimension, you see that. Okay, so now we're going to go to the high dimension. So it's beyond 2 by 2. Right. So in the 2 by 2 case, I talked about these differences because it's simple. I can write it. You might, but it really doesn't matter because you can just compute all 4 quantities and you get the complete picture, right? You should just do that and then look at it and then see how that relates to your hypothesis. But the dimension I did rapidly increases as the number of levels on treatment increases. So when I say levels, that's meaning like the level within the treatment. So if it's binary, there are 2 levels. If it's, so you can see it's exponential increase, right? If you have 3 trichotomous treatments, 27, and so on and so on. And here's an example that sort of motivated this research originally. And I think it sort of fits in this method that I talk about, fits in this framework. So this Jens and Dan and Pepe had this nice paper in PA. It's looking about conjoint analysis. So basically they've done the survey experiments to measure immigration preferences. The way they did it, they got some representative sample of American adults, and they basically had a profile for immigrants, randomized across different dimensions, and then asked people which immigrant you'd accept as a citizen. And so here there's I think 9 dimensions. So gender, there's 2 categories, 2 levels. Education, 7 levels. Origin of country, 10 levels, and so on. There are lots of dimensions. So if you multiply this all together, it's over 1 million treatment combinations. Okay? So that's, you're never going to be able to estimate precisely each treatment combination. So you have to somehow summarize. There's nothing wrong with doing that, but you just have to figure out a way to summarize this information because you got 1,300 observations. Okay, so the question here is that what combination of profiles characterize unpreferred or preferred immigrants, right? So you want to somehow characterize. And so we're going to focus on interactive interpretation, right? So that's somewhat already implicit here. It's like an interaction that interaction that they're looking for is an interactive nature, not the conditional. It's not the question of does the effect of education changes depending on your country of origin. If that's the case, you would look at the conditional interpretation. But here it's clearly at least one clear motivation is an interactive